Hello students, today I am going to discuss the new topic from the chapter Equilibrium, that is Law of Chemical Equilibrium. Law of Chemical Equilibrium discuss ചെയ്യുന്നതിന് മുമ്പ് നിങ്ങൾ Law of Mass Action എന്താണെന്ന് അറിയണം. Please listen. We can consider a general reaction. A moles of A reacts with the B moles of B to form the products C moles of C and D moles of D. Then, according to law of mass action, the rate of this chemical reaction is directly proportional to the product of molar concentration of the reactant A and the molar concentration of the reactant B. Okay, molar concentration. So B എന്ന് എഴുതിയിട്ട് ഇങ്ങനെ ഒരു സ്ക്വയർ ബ്രാക്കറ്റ് ഇട്ട് നമുക്ക് അതിനെ molar concentration എന്ന് വായിക്കാം. Okay, concentration in terms of molarity. And yes, here each concentration term is raised to the power. The power of the concentration term is equal to the number of moles in the balanced chemical equation. Okay, then what is meant by law of mass action? Law of mass action states that rate of a chemical reaction is directly proportional to the product of molar concentration of the reactants, in which each concentration term is raised to the power which is equal to number of moles in the balanced chemical equation. Okay, or here rate is equal to K into molar concentration of A raised to A into molar concentration of B raised to B. Here K is a constant called rate constant of a chemical reaction. Yes, next നമുക്ക് law of mass action base ചെയ്തുകൊണ്ട് law of chemical equilibrium എന്താണെന്ന് നമുക്ക് നോക്കാം. Please listen. Law of equilibrium. Law of equilibrium, law of chemical equilibrium is nothing but equilibrium constant. Equilibrium constant. Equilibrium constant. Yes, its symbol is Kc. Okay, we can consider a general reaction, a general reversible reaction. Please listen. For a general reversible reaction, A moles of A reacts with the B moles of B to form C moles of C and D moles of D. Okay. Then according to law of mass action, we can say the rate of forward reaction, that is RF, is directly proportional to the product of molar concentration of A raised to A into the product of molar concentration of B raised to B, or RF is equal to Kf into molar concentration of A raised to A into molar concentration of B raised to B. Where Kf, please listen, Kf is a constant called rate constant for the forward reaction. Okay, then അതുപോലെ നമുക്ക് എന്ത് പറയാം, അങ്ങനെയാണെങ്കിൽ in the case of backward reaction, yes, we can say backward reaction കേസിൽ the product becomes reactant. അപ്പോൾ സിയും ഡിയും backward reaction നമുക്കറിയാം reactant ആയിട്ട് ആക്ട് ചെയ്യുന്നു. Yes, then according to law of mass action, the rate of backward reaction is directly proportional to the molar concentration of C raised to C into molar concentration of D raised to D, or yes, RB is equal to Kb into molar concentration of C raised to C into molar concentration of D raised to D. Then we know at equilibrium, suppose this reversible reaction attains equilibrium state, then RF equal to RB. Okay, the rate of forward reaction becomes equal to rate of backward reaction. That is Kf into molar concentration of A raised to A into molar concentration of B raised to B is equal to Kb into molar concentration of C raised to C into molar concentration of D raised to D. നമുക്ക് ഇനി കോൺസ്റ്റൻസിനെ ഒരു ഭാഗത്തേക്ക് ഷിഫ്റ്റ് ചെയ്യാം, മോളാർ കോൺസെൻട്രേഷനെ മറ്റേ ഭാഗത്തേക്ക് ഷിഫ്റ്റ് ചെയ്യാം. Then Kf by Kb is equal to molar concentration of C raised to C into molar concentration of D raised to D divided by molar concentration of A raised to A into molar concentration of B raised to B. Okay, in equilibrium. Okay, the equilibrium molar concentrations are equilibrium state product in a molar concentration, reactant in a molar concentration. We know a constant by a constant is a constant. That means here Kf by Kb is a constant. That constant is called equilibrium constant in the case of a reversible reaction. Okay, equilibrium constant, Kc, equilibrium constant in terms of concentration, in terms of molar concentration. Then yes, we will get Kc is equal to molar concentration of C raised to C into molar concentration of D raised to D divided by molar concentration of A raised to A into molar concentration of B raised to B. Yes. Then what is meant by equilibrium constant? Equilibrium constant is the ratio of the product of the molar concentrations of the products to that of the reactants, in which each concentration term is raised to the power which is equal to number of moles in the balanced chemical equation. Equilibrium constant എന്നത് equilibrium state product in the molar concentrations in the product reactant in the molar concentrations in the product ratio ആണ്. ഇവിടെ ഓരോ concentration termiനെയും നമ്മൾ പവറിലേക്ക് റൈസ് ചെയ്തു. The power of the concentration term ഏതിന് ഈക്വൽ ആണ്? ഈ ബാലൻസ്ഡ് കെമിക്കൽ ഇക്വേഷനിലെ number of molesന് ഈക്വൽ ആണ്. Okay? Then please listen. In the case of gaseous reaction, gaseous equilibrium, we can replace the molar concentrations by partial pressure. Okay, for gaseous reaction case this molar concentration we can write partial pressure of gas, individual pressure of gas. The pressure of gas is always directly proportional to molar concentration. Okay, then in terms of partial pressure, the equilibrium constant expression is Kp is equal to molar concentration of C into place we can write Pc raised to C into Pd raised to D divided by Pa raised to A into Pb raised to B. Okay, this is the equilibrium constant expression in terms of partial pressure. Then next, what is meant by homogeneous equilibrium and heterogeneous equilibrium? Okay, then അതിനു മുമ്പ് ഒരു കാര്യം ഞാൻ പറയാം. Okay, this expression yes indicates the law of chemical equilibrium. Okay, then according to law of chemical equilibrium, equilibrium constant is the ratio of the product of the molar concentrations of the product to that of the reactants, in which each concentration term is raised to the power which is equal to number of moles in the balanced chemical equation. Yes, then please listen. The next topic, homogeneous equilibrium and heterogeneous equilibrium. What is the difference between homogeneous equilibrium and heterogeneous equilibrium. But types of equilibrium. So equilibrium can be classified into two types. There are two types of equilibrium. Number one, homogeneous equilibrium. Homogeneous equilibrium. And the second one is heterogeneous equilibrium. Okay, there are two types of equilibrium, homogeneous equilibrium and heterogeneous equilibrium. ഞാൻ ആദ്യം രണ്ടിനും ഓരോ എക്സാമ്പിൾ എഴുതാം. Okay, example for a homogeneous equilibrium. Okay, nitrogen gas reacts with hydrogen gas to form ammonia gas. Then example for heterogeneous equilibrium. Decomposition of calcium carbonate. Calcium carbonate is solid ആണ്. High temperature calcium carbonate decompose ചെയ്ത് calcium oxide solid carbon dioxide gas form ചെയ്യുന്നു. Then what is meant by homogeneous equilibrium? In homogeneous equilibrium, the reactants and products exist in same phase. For homogeneous equilibrium case, reactant in the physical state product in the physical state same ആണ്. But in the case of heterogeneous equilibrium, reactants and products are in different phase. For heterogeneous case, reactant in the phase product in the phase different ആണ്. Here, ഇവിടെ നോക്കുക, reactant ആയ calcium carbonate solid state exist ചെയ്യുന്നത്. But here, product ആയ carbon dioxide gaseous state exist ചെയ്യുന്നത്. ഇതാണ് രണ്ടും തമ്മിലുള്ള difference. Okay, students. In my next video, I will discuss the next important topic from this chapter, that is the factors affecting equilibrium. For equilibrium state in affect ചെയ്യുന്ന factors, Le-Chatelier's principle base ചെയ്തുകൊണ്ട് നമ്മൾ പഠിക്കാൻ പോകുന്നു. Okay, we are going to study the factors affecting equilibrium on the basis of Le-Chatelier's principle. Okay, goodbye, study well.